Hi everyone, this is Abrar. I wanted to make one quick follow-up video on Cp and Cpk. As you know, Cp is process capability ratio and Cpk is process capability index. Let's get brush up what we saw in session 1. So in session 1 what we concluded, if the width is more, that means variation more. If the variation is more, that means we will have more rejection. So in order to have a Six Sigma, it should be well within the specification. So LSL and USL should be half of the overall width. That means it's considered to be a Six Sigma. To have a Six Sigma, the yield will be 99.999967, or in other words, defect percentage will be 3.4 defect per million opportunity. If we happen to make 1 million product, that means the allowable defect is 3.4. So Cp and Cpk is a part of the measurement phase in Six Sigma. In Six Sigma pretty much follows the DMAC approach. DMAC stands for define, measure, analyze, improve and control. So this Cp and Cpk used to measure the capability of the process. So we saw like why we need CPK. What is the necessity of the CPK? In CPK, this is one example. If in this particular example, CP is a customer specification where it is all the values you can see are falling in the lower range, lower specification. Although it is a good, that means it is not having any rejection, but still all these values are falling within the specification. But only thing is it is one-sided lower specification. But in what the CPK concept is, it brings the process into center. When you bring the process into center, that means the variation we can control and the process will become robust. In this particular example, Cp formula, as you all know, USL minus LSL by Six Sigma. You can see this chart like 0.7, anything which is less than 1, that means process is not capable. So it may end up producing more rejections, more defect products. So in this on the right side you may see like the specification, design specification is 20 to 30, but actually the few values have fall between 18 to 20, that is also called them as a defect. Few values are in the range of 30 to 32, that is upper than the upper limit, that is also a defect one. So anything which is greater than Cp value is 1, it is good to have. So CPK, the very important factor about CPK is CPK takes a process grand average into consideration. What I mean by grand average, meaning like X bar, whatever the process average is there, that takes into the equation. So the formula of CPK is a minimum of, you can use USL or LSL minus X double bar, that is process average, by 3 sigma. So you can see that CPK, it brings the process into center. That means will be well within the specification. So you can see on the right side, if the CPK is 0.33, that means it's 1 sigma, and all the way go down. If the CPK is 2, that means it's a 6 sigma. So in this following video, we also have one quick example where I drawn up with the whiteboard. So by using the formula, how we can know, if we know the CPK value, we can get to know the sigma level automatically. That was first session conclusion. What we concluded was CPK compares the value with the customer specification. It doesn't take the process average into consideration. That's what we saw in the first session. Let's see in session 2 what we're going to cover up. We're going to cover up what if the Cp is equal to Cpk, what the value, how the bell curve will be. If the Cp is not equal to Cpk, how the range and how the bell curve will be, and we have a quick calculation and the bell curve. This is what you may magnify, that actually if the Cp and Cpk is equal to 1, that means it's a 3 sigma. the process is 3 sigma. If the Cp equal to 1.33 and both the value is 1.33, then process is 4 sigma. If Cp is 1.67 and both are 1.67, that means is a 5 sigma, and Cp is 2. Cp and Cpk is 2, it means 6 sigma. So this is the one quick one where I applied the formula. Cp, I have taken two examples. One is Cp and Cpk equal to 1, and one more example is Cp and Cpk equal to 1.67. So you all know USL minus LSL by 6 sigma is Cp, and Cpk is USL minus X double bar by 3 sigma. Substitute Cp in Cpk. Here the value of Cp is 1 and USL minus 0. The very reason why I have given 0 for X double bar is because process average is 0 when both the values Cp and Cpk becomes equal. So 0 by 3 sigma, if you cross multiply 3 sigma. So when we know Cp and Cpk value, so we can also determine the sigma value automatically with the help of these formula. Take another example, the same range. So Cpk 1.67, by applying this one we got 5 sigma. That means it will start from 2.5 if it is considered to be half width. 2.5 it will, that means we will have still rejections and variations. Take an example of when Cp is not equal to Cpk. If it is not equal to Cpk, there's a second one where Cp equal to 1 and Cpk equal to 0.83. That means we are using 2.5 sigma. So that means few of this sigma value will push towards LSL or USL. In this example, it will push towards USL. We'll see an example also as well. So in this example, Cp equal to 1 and Cpk equal to 0.83. So what we also need to know that actually the Cpk value will always equal to or less than Cp value. So Cpk equal to USL minus X double bar by 3 sigma. We know Cpk 0.83 USL minus X double bar by 3 sigma. If we cross multiply, we got 2.5. So here I have not equated with 0 for process average X double bar, because actually if Cp and Cpk are different, that means the process is not center. So in the same very example, Cp equal to 1 and Cpk equal to 0.67. By applying this, we got sigma value of 2. That means in this bell curve, whatever the shaded is black, that is rejections. So hope you like this video. If you have more questions, please do write up to me, abrar.quality1gmail.com. So thank you so much. Please do subscribe and like my channels. Thank you so much. Have a nice day ahead.